and I'm going to run us through a quick demo of the Federate. All right, great. So to start with, we have an LRS. I'm just going to log in, and we should see that it's a clear LRS with no statements. Yep, no records to display. Okay, in order to demonstrate this Federate, we have a simulation here. It's a two-dimensional world containing carrots, rabbits, and wolves. It's a predator-prey sim. The carrots grow and rot. The rabbits eat carrots. The wolves eat the rabbits. The animals move, reproduce, and die when they get too hungry. So this is a FOM. This is a federated object model in HLA. And we have a little demo sim that produces objects and interactions in line with this FOM. So the one we're going to focus on for this demo is entity 8 interaction. Just going to find that here. These are all the objects, the wolves and carrots and rabbits. Here we have entity 8. Okay, and that has a predator ID, which is an ASCII string. It has a prey ID. It has a position, and it has what type the predator and prey were. So this, in combination with this config file, are all we give the Federate in order to instrument xAPI from an RTI from HLA. So this is an example of a statement trigger, and I'll go through the component parts here. So first is just what type it is. There are 4 types. We'll go through the others in a second, but this one's an interaction. These are all interactions here. And the interaction's name is entity 8. This is criteria if you want to limit when it triggers and when it doesn't. In this case, it's more for illustration because the predator is never the same as the prey, but this is basically saying the predator's ID does not equal the prey ID. These are the attributes in that interaction. So in the FOM here, predator ID, prey ID. This can be used to basically filter out interactions that are not necessarily representative of where you want an xAPI statement generated. So we're going to skip lookups for a second and just go down to statement. This should look familiar to anybody who's familiar with xAPI. This is effectively just an xAPI statement. It is the same JSON notation as any xAPI statement. It just has a specific syntax for injecting data from the HLA. So we'll do the simple ones first. Trigger, we already saw that in the criteria. What that means is dependent on what type it is. So in this case, it's an interaction. So this means the interaction itself is the trigger. So it's basically saying what triggered this statement. In this case, it's the entity 8 interaction. And then inside of that, you have some target where you can say what attribute you want. So in this case, predator ID. Same thing down here for the object. The name is trigger prey ID. We're just grabbing those directly out of the interaction that comes in over the RTI. These are a little bit more complicated. You can ignore the escape syntax here. These are really just the same kind of syntax as this. They're just arrays. But a lookup is saying, hey, go to the cache and get something that we've cached about possibly these objects. And up here, we define what those objects are. So predator and prey are actually aliases. So we're saying a predator is the sim entity from the cache where the entity ID equals predator ID from this interaction. Similar for prey, it's the sim entity where entity ID equals the prey ID. And then the reason for that escape syntax is we're putting them together in a string. We're just doing like a string injection where we're saying first name, last name. So these are 2 different cache lookups. And we do the same thing for the prey. So this is all we have to give Federate xAPI in order to generate this statement. There's a couple more statements here, and we'll go through those in a second. And then you also have to give it the LRS information so that it knows where to put the statements. So with that being said, we will start up an RTI and get this running. So we're just using a Portico RTI here. That is started. I'm going to run the Federate first. That way it catches all the data. In this case, I'm running it on top of Postgres. You do not have to have a separate database. There is a default SQLite implementation, which will just run on the hard drive. It'll just cache everything on your hard drive. I'm running it in Postgres so that we can actually see the database and see the cache in action. And I will explore that here. Should see, yep, HLA object cache. And now we can actually see these objects. I have not run anything yet, so this will be empty, but it does know what the objects in the FOM are, and it's initialized everything from starting up. So now we're running, we don't have any statements, we don't have any data. Let's actually run a simulation. So this is that predator prey sim that I mentioned. And here comes some wolves and rabbits and carrots. So they're dying and eating each other and doing all sorts of things. And we'll just let them go a few steps in the world, and then I'll stop the sim. And what actually right there on the logs, see this? We stored a whole bunch of statements. These were all buffered statements that came from interactions or object updates that happened that we were triggered on. So we'll go back to that LRS, and here we go. Now, if I take one of these statements and blow it up, this 8 statement, this is actually identical to the statement that we wrote over here. So we have our actor, agent, and then name, first name, last name. So this is coming from our SQL cache. And then this ID is coming directly from the entity 8 interaction. Verb 8, just like in what we designed, and name and ID for the prey as well. So there are a couple of more different types of interactions. I think we have most of them in this example. So object update is updates came in about a given object for the cache. That will do 2 things. It'll update the cache, and then potentially if you set up a trigger like this, it will, it'll actually trigger a statement based on that update. One of the cases that we considered is if you have an object that updates and maybe some attribute of that object changes state, like it changes a level from 5 to 4, that's when you might want to trigger a statement. So that's where you put criteria. And in this case, this is just kind of a world tick statement. And those should be in there too. Yeah, I think it's advanced is the verb. Yep. The other kinds are just object lifecycle, so object created and object deleted. I'm going to go back over those injection syntaxes that we used. Let me find. This is our docs. This is all public. Again, this is Apache 2. You can download this. And actually, you can even download our Rabbit sim if you want to try something with it. But we have the lookup syntax where you're looking at something that's already been defined, something that's been aliased. The longer form of that is a query syntax, where you're actually putting the condition right into the injection. So this is almost the same as saying lookup, but in this case, you're actually including the condition, so you're not really caching that as an alias. You're just doing a raw lookup from within the statement. Previous is contextually specific. It's when you have an object update, the previous keyword will be the previous state of the object. So that's when you need to make comparisons, like something changed, you don't know what direction it changed, or if it changed from true to false, or if it changed in different ways. And then trigger we went over, which is really just the event that triggered the simulation, or sorry, that triggered the statement in the first place. The only other interesting one is trigger will mean the last state of a deleted entity before it was deleted, because a delete does not come with data in the RTI. So trigger will just mean the last cache state before the end. Some other notes, we are doing xAPI validation on all of these statements. And not only that, but we're doing FOM interrogation. So the FOM is very detailed about what data types are. So we know down to primitives what each piece of data is going to be. So if you try to inject a piece of data into a statement in a place where there's a data type mismatch, let's say it's a numeric field in xAPI, but you try to inject a string, it will actually do that validation and tell you, that's not correct. It will also tell you if just your statement is not valid xAPI. So it has built-in validators for those things so that you don't end up losing statements at the sort of LRS boundary. But yeah, that's the demo. I guess we're still running here, but yeah, it's done getting statements from the sim, and that's Federate xAPI.